In this video, we're going to talk about how to graph polar equations. So first, make a table of r values corresponding to various values of theta for 0 to 2 pi, and round to the nearest tenth. Then graph the ordered pairs r theta and connect the points with a smooth curve. So let's do an example. Given the equation r equals 1 minus cosine of theta. So I have made a chart for all of my theta and the corresponding r values from 0 to 2 pi, and I've just taken known increments. So what you would do was plug in the value for theta into your equation, r equals 1 minus cosine theta, and solve for r. So if you're solving for theta equals 0, we'd have r equals 1 minus the cosine of 0, which is 1 minus 1, which is equal to 0. So you'd put in a 0. For pi over 6, you would have r equals 1 minus cosine of pi over 6, which is equal to 1 minus square root of 3 over 2, which is equal to 0.1. So you would continue to fill in your table in this way for every value. Now you will graph this on a polar coordinate system. So this will look, we have our 4, so this is 0, this is pi over 2, this is pi, this is 3 pi over 2. And then we've broken it down by pi over 6. So we have, for here we have pi over 6, we have pi over 3, we have 2 pi over 3, 5 pi over 6, 7 pi over 6, 4 pi over 3, 5 pi over 3, and 11 pi over 6. We've gone up in increments of pi over 6. Now we will draw a circle here. This is our 1, and this is our 2. So our diagonal lines correspond to our theta value, and our rings correspond to our r value. So if we start by plotting 0, 0, that will be right in the middle. Now, pi over 6, which means we're going to be on this diagonal line right here. And then we're going to go 0.1 out. So that's very close to our original point. Then pi over 3 is at 0.5, so that's right here. Pi over 2 is at 1. 2 pi over 3 at 1.5. 5 pi over 6 is at 1.9. Pi is at 2. 7 pi at 6. And so now you can see we're going back down the exact way we came. So we're going to have some symmetry here. So now we must connect these in a smooth curve. So when we do that, we get something that looks like a lily pad. So we can see that this is symmetric, and it's symmetric in respect to the polar axis, which is this line from 0 to pi.